Welcome to our instructional lab video on spectrophotometry. Before we begin with our lab today, we need to cover some lab safety rules. You need to be wearing lab attire. Remember to always wear your goggles as we are handling an acid base. Because we are using an acid base, remember to keep ammonium in the fume hood. As you are using the fume hood, make sure that you do not pull the hood all the way. Stop at the line, then take the amount that you think you need.
The following objectives for this experiment: learn to prepare multiple standard solutions, analyze data using the spectrophotometer, understand the relationship between absorbance and concentration. The materials that you will need to collect for this experiment are 4 beakers, a volumetric flask with the cap, bore pipette, ammonia, plastic pipettes, stock solution, unknown solution, 5 cuvettes, and the spectrophotometer.
After gathering your materials, it is time to create the stock solution in serial dilutions. For the stock, you will try to aim for 0.125 grams of copper sulfate. Add a small amount of water to the copper sulfate inside the volumetric flask. Once it dissolves, go to the flame hood and slowly add ammonia until the solution is a clear dark blue color. Cap the volumetric flask and mix it. You will then transfer the copper amine solution into a beaker for the next step. To begin the dilution process, first prime the pipette by putting a small amount of blue solution into the pipette and coating the inside thoroughly. Repeat this roughly 3 times. After priming the pipette, use it to measure 5 milliliters of copper amine stock. Transfer it to a volumetric flask. Dilute with water to the line. It is important that the meniscus does not pass the line on the flask. You will repeat this process for the remaining dilutions. The next step is to prepare the unknown solution with the same dilution steps. After that, transfer all the dilution, stock, and unknown into the cuvettes with a plastic pipette. At this part of the experiment, you should have 6 cuvettes: a blank solution with water and ammonium, stock solution, dilution 1, dilution 2, dilution 3, and the unknown.
The Beer-Ambert law is used to show a relationship between absorbance and concentration. This slide shows the variables that are used in the equation. The Beer-Ambert law can be used to make a calibration curve, which can also be graphed with the equation y equals mx plus b. A is absorbance, epsilon represents the molar absorption coefficient, c is concentration. B, or L, is the length of the path of light. In the graph here, we have y as absorbance and x as concentration to show a direct relationship. As concentration increases, absorbance increases. An R value close to 1 will show the accuracy in the graph values. The calibration curve is used to find the unknown solution's concentration based on its absorbance. You can also substitute absorbance in the slopes-intercept form from the calibration curve to solve for x, which we established as concentration. The manipulation of the dilution equation is shown here in the notebook. You can first start with the concentration of stock solution to find the concentration of the ensuing dilutions each time.
The third exercise includes using the spectrophotometer. At the spectrophotometer, scan the wavelength and absorbance of the dilutions. Begin by opening the scan program and scanning across all wavelengths to determine where the highest peak of the absorbance for the stock solution is. Another reason why it is important to scan across all wavelengths is to ensure that you get the most accurate absorbance for your solutions, because if you do not determine the correct peak, then your calculations and data will be inaccurate. The scan tells you what value your lambda max is, which is the wavelength of a substance where the strongest photon absorbance is. Before beginning your scans and simple readings, make sure to use the blank solution to zero out at the appropriate times. Clean both sides of your stock solution using a lab tissue and place it in the spectrophotometer and press the start button. Looking at the scan result, we can see that the peak is anywhere between 560 and 600 nanometers. Now open the simple readings program and set the lambda max value to your chosen value from the scan. Clean both sides of the blank cuvette and place it in the spectrophotometer to zero out the readings. Then place your stock solution cuvette in after cleaning both sides and click Start. Continue this process for the remaining solutions, remembering to clean the sides of the cuvettes.